So, in last lecture I was discussing about the slide calipers. So, basically what we have discussed that slide calipers have mainly these three parts which are very useful. So, this upper jaws is called basically inner measuring jaws, then this one is called the outer measuring jaws, and this tail it is called the depth measuring prong or tail. Okay. And then this the main scale and this then vernier scale. This retainer, as I showed that to tighten it at a particular place. So, to retain it basically we use it. Okay. And this is the vernier scale. So, that we have I have shown you, and then I have discussed about the zero error. So, as 0 of the vernier, if it coincide with the 0 of the main scale, then 0 error is nil, and if 0 of the vernier is at the left of the main scale 0, then we tell this negative error. Okay. So, what is the value of this error? So, that we have to see this which division of vernier scale is coincide with the main scale. Okay. So, here you can see this seventh vernier division, that this line coincides with this main scale line. So, this error, negative error will be minus 7 into vernier constant. So, if vernier constant it is 0.01, so then it will be 0.07 minus 0.07 centimeters. So, that is the error, and it is the negative error. And if vernier constant is 0.002, then that will be here it is of course, because 10 divisions are there. So, it is the 0.01 centimeter is the vernier constant, but other case here. So, this here this vernier constant is 0.002. So, one has to find out the 0 error depending on the coincidence of the one division of vernier scale with the main scale line. Okay. So, this one for this is the positive negative error, and this one is positive error. Okay. Because 0 of vernier scale is at the right of the 0 of the main scale. Okay. So, here I think which line coincides. So, this sixth division or sixth line of vernier scale coincides with the main scale line. So, vernier, so 0 error is basically 6 into 0.01 centimeter. So, that is 0.06 centimeter, and this is plus 0.06 centimeter. So, that is the 0 error. Okay. And yeah, if we ask you this what is the reading in this case. Okay. What is the reading? So, then you have to find out what is the main scale reading. As I told that which will be the main scale reading? No, this just at the left of this 0 of vernier scale. So, that is the main scale reading. This line is just at the left of the vernier 0. Okay. So, it is the 1233 millimeter, that means 0.3 centimeter, that the main scale reading. And what will be the vernier scale reading? So, vernier scale reading we have to find out that how many division here, which division or which line of vernier scale coincide with the main scale. So, here I think this one is the better one, or this one, whatever. I think here red mark is there. So, it is taken as a coincidence line. Okay. So, but one can take this one also. So, here, so that solves the error bar, plus minus this one least count that is taken as error. So, if I take this one, so this one is I think this is 20, 21, 22, 23, no, these are I think 5, I think 25, this one 25, 26, 27, 28, 29. Okay. So, this is the 29th vernier line coincide with the main scale line. So, vernier reading is 29, vernier constant in this case is a 0.02 millimeter, means 0.002 centimeter. So, vernier scale reading will be 29 into this vernier constant. So, it will be 0. I think it will be 58, yes, 0.058. So, that will be the vernier scale reading. Okay. So, total reading will be 0.3 centimeters plus vernier scale reading 0.058 centimeter. So, total reading will be 0.358 centimeter. Okay. Now, you have to take care of this 0 error if any. So, then this reading minus, that will be taken final reading minus the initial reading, that is the 0 error. Okay. So, in case of negative, so I have to minus minus in this case whatever we saw this I think 0.06, but here vernier constant is different than this one. So, what I want to say, so this minus this in 0 error. So, it will be plus, in this case minus of plus this reading. So, that will be actually minus. So, final reading minus, or it will be in case of positive error, it will be minus of this 0 error, and in case of negative error it will be plus of this 0 error. Okay. So, that will be the final reading. Okay. So, as I showed this this screw gauge, as I have shown earlier. So, this screw gauge, right. So, it has 0 error, it has no 0 error, as I showed you, it has no 0 error, right. It has no 0 error, it has no 0 error, it has no 0 error. Okay. So, this is used for, as I told, this inner measuring jaw. So, now what is the use of that? So, now if I ask you what is the internal diameter of this cylinder. So, then this is the use of this one and this, say, so this one. Okay. So, this is the inner diameter. Okay. You cannot measure inner diameter using this one, because this you see, this is for external, this is good for external, as I describe you. Okay. This parallel, these two edge of the jaw will be used for measuring, right. So, this is the for measuring for external diameter, this will be used for internal diameter. Okay. Now, if I ask you what is the depth, what is the depth of the cylinder, then how we will measure the depth of the cylinder. Here in this case is both end are open, but if one end is, so then you can measure. So, this way one can measure. Okay. So, because depth and this from this outer this length and depth are same, but imagine if this one end is closed, okay, and it has some thickness. Okay. So, then external this length is not same as the depth of that one. So, in that case to measure the depth, so basically it is this other part is used, this tail or prong is used. Okay. So, this part, so this basically this way. Okay. So, this basically you are using for measuring depth. So, what is the reading one has to find out, what is the reading one has to find out. Okay. So, it is not difficult to find out. Here I can see 1-2 centimeter and then 2 then 1 2 3. So, 2.3 centimeters, and then after that 0 vernier 0, and then I have to see how many division coincide with it. So, it is around 25, around 5, that there 5 means 25 division or 26 division or 27 division almost is coincide with the 27 division. Here you see it is coincide with the bend scale division. Yeah. So, 27 one can take. Okay. So, 27 into this vernier constant. So, that will be the vernier reading, and so main scale reading plus this vernier reading. So, that will be the final reading minus initial reading, it is 0 because 0 error is nil. So, that will be the depth. Okay. So, this is the use for measuring the internal radius or diameter, external diameter, okay, and this depth of this cylinder. Okay. So, this slide calipers is very useful, which you cannot do with the meter scale, except. So, this it is not only for the lower least count, better least count, but it is for other advantage also for using these slide calipers. Okay. So, then I think I will go yes. So, using this slide calipers, one can measure the volume of the different regular shape. Also, as I told you that this if you want to yeah, of course, if you want to find out the volume of this cylinder also, you can find out. Okay. Internal volume, external volume. So, whatever, so that is possible because you have to measure the radius. So, from diameter we can find out the radius and then use formula, then you can measure. Okay. Then next I will go for this screw gauge. So, another tools for measuring the length. Okay. So, that is the screw gauge. So, this is my screw gauge, I think. Yeah. So, this is screw gauge. So, screw gauge also used for measuring the length. Okay. So, so this screw gauge again, its least count is better than the slide calipers. Its least count. So, in this case also you have to find out, first you have to the same way. So, I think yeah. So, first you have to check whether is there any 0 error. Okay. So, in this case what are the things? Okay. So, here, so whatever object, whatever the length of the object you want to find out, it can be diameter, it can be the thickness. So, this is used for very thin wire, this very thin this thickness of plate. Okay. So, for those items or body we use this slight this screw gauge. So, that body is placed between these two, okay, these two parallel faces. So, what are the name of them I will just tell you. Okay. I think I can show you different parts. So, it is the, so this part is I think this part is called anvil, okay. This part is called screw, okay. And this is called this, here this basically two scales are there. One is circular scale, this circular scale, okay. So, in this case it's 0, 1, 2, 3, so up to in circular scale this total 50 divisions are there, and then this is called this main linear scale, circular scale and linear scale. So, in linear scale these the divisions are in millimeter. So, and so this the circular scale, okay, and this called ratchet, this called ratchet, okay. So, this helps to know that when you are putting any body to measure the thickness or diameter of any wire. So, you put the things, then you are pressing. So, how long you should press? So, after just touching it, if you just use this one, then it will just give a sound. That means, then you are you can stop this pressing. Okay. That means, this is the right position for this thickness or diameter, and then you should take reading. Okay. So, this is the instrument is called screw gauge. Okay. So, here also basically here also basically first one has to see the whether there is any 0 error. Okay. This case also, this when if you just if you if these two just coincide, touch each other. So, then in that time you have to see, yeah. So, then you have to see this yes, that 0 mark on the circular scale, 0 mark on the circular scale, okay. 0 mark on the circular scale, 0 mark on the circular scale, whether it coincide with this linear line, whether it coincide with the linear line. So, it seems it is, I think, yes, it's some mark is there, yes, I think, yeah. So, if it is this way, okay. So, if it is like this, you can see 0 mark on line on the circular scale, it coincide with the main scale that or linear scale that mark, okay. Then we tell this 0 error is nil, but in this case there is a error I can see. So, it is basically it is like this, you see 0 didn't coincide with this linear, I think it is a reflection. I should, you can see 0 is just cross this linear scale that mark, and it has gone just I think few division of. So, 0 of circular scale, it crossed this linear scale, that mark. Okay. So, this is one type of error. If it cross, then we tell that is the I think it cross means 0, it has crossed. So, it will give some extra initial error, Okay. So, then whatever final reading will be there, so that should be subtracted from there. Okay. So, then it is basically positive error. Okay. Now, if it does not cross, it is just it could not reach to the scale, that mark on linear scale. So, then it will be negative error, because it could not reach. Okay. So, these three cases, one is 0 error nil, one is 0 error nil. So, it coincide. Okay. So, this 0 line on the vernier circular scale, it coincide with the 0 line on the linear scale. Okay. So, this is error is nil, and here you see, okay. So, I think that 0 could not reach to the vernier circular 0 could not reach to the 0 of the linear scale, then it is a positive error, and 0 of this one, it crossed the 0 of the linear scale, then it is negative error. Okay. So, that is what I think earlier also we have described in same way, right. So, in vernier scale also, slide calipers also, what we have told that when 0 of the vernier scale, if it could not reach to the 0, okay, then it is positive error. If it cross it, okay, so then it is negative error. Okay. So, in this case also, when you are rotating the scale, okay, so when you are rotating and when this touch, and then if it could not, when the 0 of the circular scale, it could not reach to the 0 of the main scale, then it is positive error. If it reach and then cross it, then it is negative error. In meter scale also, okay, if you just initial reading, if it is more than 0, means it is that towards the I think if it is towards the right. Okay. So, that means could not reach to 0 like this. Okay. So, then it is a positive, means just minus of this one. If it cross this 0 in main scale, so then we have to add it with the, so that with final reading. So, we have to add this initial reading, that means from definition final to final minus initial. So, that one has to be minus of this error. So, minus of minus this initial reading. So, that will be plus. Okay. So, this is the so in this case, in screw gauge also, this we have to find out the 0 error, and that 0 error is nil in this case, 0 error positive in this case, and 0 error negative in this case. And your reading, total reading, now here linear scale reading. So, it is the main scale reading. In vernier we told main scale reading. So, here we tell linear scale reading, and then plus circular scale reading. There we tell vernier scale reading, here we tell circular scale reading into least count LC. So, their Vernier constant whatever you took, that is the here it is least count, okay, minus. So, this will be the final reading minus initial reading. So, that is the 0 error. Okay. So, now I have to tell you how to find out the least count. So, this again this here you see here first 0 error, after that here you see if I just rotate, by 1 complete one circle. So, you can see here it has come out this okay. So, I think one rotation I have given, I should give more, then you can see the linear scale. Okay. One rotation I have given, then 2 rotation, then 3 rotation, okay, then 4 rotation, okay, then 5 rotation I am giving, then 6 rotation I am giving, this 7 rotation I am giving, 8 rotation I am giving, 9 rotation complete rotation, and then 10 complete rotation. So, now you see, you can see the linear scale. So, 10 rotation complete rotation I have given. So, in linear scale, you see what is the reading in linear scale. Okay. You can see reading in linear scale, is basically you can see it is 5 millimeter. Okay. It is the 5 millimeter, whether you can see or not, you see it is 5 millimeter. So, 10 complete rotation, it is the 5 millimeters in linear scale. So, this gap, okay, it is a 5 millimeter. Okay. So, basically now for one complete rotation, what is the reading in linear scale? So, it will be 0.5 millimeter. Okay. So, that 0.5 millimeter is called the pitch. Okay, is called the pitch of the is called pitch. So, for one complete rotation, whatever the reading in linear scale reading, so that is called the pitch. Okay. So, this least count is defined as here I have not written. Okay. So, I think I have not written. Least count is defined as yeah, it is here I can show this least count is defined as the pitch of the screw gauge, divided by total number of divisions of circular scale. So, pitch of the screw gauge, as I showed you, the 0.5 millimeter, and the total division in circular scale is the 50. So, you are getting this 0.01 millimeter. So, that is 0.001 centimeter. Okay. So, this is the least count. Now, when you will measure, so taking reading also same, here you have to find out the what is the reading in linear scale. Okay. So, in this case it is the, as I told, that is a 10 division, the 10 I just rotated by 10. So, but you do not need to count. So, that will be given by this linear scale. So, it is the 5 millimeter, and then some crossed some reading is you can find out. So, this 0. So, then you have to find out what is the reading. Actually, this in linear scale, that mark, okay, this mark. So, which line on the circular scale this coincide with this mark, okay, linear mark. Okay. So, that division you have to find out. So, here that division is division is say it is in this case whatever is 40. Okay. So, 40 is the circular scale reading, and least count is 0.001. So, it will be 0. That is a 40, 0.040. Okay. So, that is 0.40. So, that will be the circular scale reading, and then linear scale reading is in this case 0. I think 0.5 millimeter means 0.05 centimeters, and for 40 it has come 0. Oh, that will be I think 0.0040 into 0.001. So, it will be 0.04, 0.04, no, it is a 0. I have to calculate, just 1 minute. So, if I get circular scale reading, this is 40, and then into Vernier least count, that is 0.001. Okay. So, that will give you 0.0 I think 40 centimeters. Okay. And your main scale reading was that was 5 millimeter, sorry. So, that is the problem. So, linear scale reading was 5 millimeter. So, means 0.5 centimeter. Okay. So, now this plus this, these two will give you that 0.540 centimeter. Okay. So, this will be the reading. Now, this as we told that we have to take this final reading minus the initial reading, that error, if any error is there. So, in this case I told you some error was there. So, it just crossed this 0. So, that was a negative error. So, that reading was around 5 division. Okay. So, that negative error was so minus 5 into 0.001 least count. So, that would be the error. So, minus plus 0.005. Okay. So, this will be added here. So, this final reading minus of minus 0.005. So, minus plus. So, ultimate reading will be 0.545 centimeter. Okay. If 0 error is negative, and if it is 0.005 means fifth circular scale division line, it coincide with the linear mark. Okay. On the linear scale. Okay. So, this is the initial reading that is coming from 0, and that is the final reading. So, final minus initial, that will give you the total reading. So, that total reading is in this case 0.545 centimeter. Okay. So, this way one can use the screw gauge basically for measuring the thickness or diameter of the very thin wire. So, this screw gauge is very useful, and it gives better accuracy. Okay. So, meter scale, slide calipers, screw gauge, so all for measuring the length. Okay. So, it can be diameter, it can be inner depth, okay. It can be diameter of cylinder, it can be diameter of the wire. So, where you will use this which one. So, you have to judge for so to reduce the error. So, you have to use screw gauge when this diameter or length of the object is very small. Okay. So, I think these are the basic tools for measuring the length. So, I will stop here. Thank you for your kind attention.